Okay, we're continuing section 1.5, proofs that are not valid. If we look at example 1, it's talking about Hayley Wickenheiser. It says athletes do not compete in both the Summer and Winter Olympics. Hayley Wickenheiser has represented Canada 4 times at the Winter Olympics. Therefore, Hayley Wickenheiser has not participated in the Summer Olympics. If we look at this, we can use reasoning to determine the validity of an argument. So if we research, we know Hayley Wickenheiser played women's hockey in our Winter Olympics, but she also played summer softball on the women's team for our Summer Olympics. So Hayley Wickenheiser has played in the Winter Olympics and she has played in the Summer Olympics, therefore proving this to be an invalid statement. We have example 2 where Bev claims that she can prove that 3 is equal to 4. So if we look, Bev breaks down, she's posing that A plus B is equal to C. So she takes 4A minus 3A plus 4B minus 3B is equal to 4C minus 3C. Then she gathers all the 4's on one side, so she has 4A plus 4B minus 4C is equal to 3A plus 3B minus 3C. Taking out the common number, which is 4, and taking out the common number on this side, which is 3. And when you divide both sides by A plus B minus C, you get 4 is equal to 3. So we need to show that this is an invalid proof. So we look, A plus B equals C. Sure, we'll go with that. Then how she broke it down, 4A minus 3A, that's the same thing as A, and 4B minus 3B is the same thing as B, is equal to 4C minus 3C, which is the same thing as C. So that's okay. We look farther and we organize the 4's onto one side and the 3's onto the other side. And when we get near the end, we've taken out the 4's and the 3's that are common. And this is the part where it falls apart because we're dividing by A plus B minus C. You cannot divide by this because this statement is 0 and you are dividing by 0, therefore making the proof invalid. Because if A plus B equals C, if you subtract the C over, you have A plus B minus C equals 0. So this would mean if you're dividing by A plus B minus C, you're dividing by 0, which is not allowed. So making this proof invalid. Another way to show a proof is invalid is if you start a claim with something that is not true. So Liz claims that she has proved minus 5 is equal to 5. Minus 5 is equal to 5, so if you squared both, you get 25 is equal to 25. This means that minus 5 is equal to 5. Where did she go wrong? Well, she started with a false assumption, a minus 5 is equal to 5, which you cannot do in a proof. So starting with a false gives you a proof that is invalid. So therefore minus 5 cannot equal 5. The other place where proofs become invalid is if you make a technical error. So this one we have n. He chose his number to be n. He adds 3, doubles both, so it becomes 2n plus 6. Adding 4 means it's 2n plus 6 plus 4, which is 2n plus 10. And then when it's divided by 2, it should be 2n divided by 2, which is n, and 10 divided by 2, which is 5. So right here, this is the point where the error was made, making the proof invalid.